Lesson 5.5, Solving Polynomial Equations. There's going to be two different lessons on this, so today we're starting with day 1. It's very similar to the factoring polynomials that we did last class. It's just going to take it a step further. So we're going to start with a small review of what we did for 5.4. Solving by factoring. Alright, so we have 2x cubed minus 12x squared plus 18x equals 0. So just like last class, we want to start with our factoring, and the first step always is your greatest common factor. Remember, we're looking at the numbers to begin with. We've got 2, 12, and 18. You want the biggest number that goes into all three of those. The biggest number that goes into 2, 12, and 18 is 2. Also have to take a look at our x's. We've got x cubed, x squared, and x. We're looking for the most amount that they all have. If you'll notice that they all at least have 1x. Your greatest common factor is 2x. Now, just like we did last time, each term has to be divided by your greatest common factor. 2 divided by 2 would cancel. X cubed divided by x, that leaves me with x squared. Negative 12 divided by 2 is negative 6. X squared divided by x leaves me with just x. 18 divided by 2 is 9. And your x's in this case would cancel. I'm going to keep it equal to 0. And just for completeness sake, that again was your greatest common factor stage. Remember that we always want to take a look at what's left inside the parentheses to see if it can be broken down any further. You should be able to recognize at this point that you have 3 terms. Our only option for factoring 3 terms would be our x puzzles. Set your x puzzle up. 9 goes on the top, negative 6 on the bottom. I'm looking for 2 numbers that multiply to give me 9 but add to negative 6. Negative 3 and negative 3 are going to satisfy that. Remember that your GCF is always part of your answer, so you want to bring that down. Don't leave him behind. Writing our answers to our x puzzle like we always have, we should have x minus 3 and x minus 3. Again, I'm going to leave that equal to 0. We know this already, but this is quad form. Also, remember, if you have 2 of the exact same things being multiplied together, you can simplify that and write it as x minus 3 squared. This would just be a simplify step. All right, this is what we did last class. Today we are solving. So what we have here are factors. We need to actually solve that. In order to do it, we're going to take each factor and set them equal to 0. So I'm going to take my 2x and put it equal to 0, as well as my x minus 3 and put that equal to 0. You don't need to worry about the squared. Solving for x, here for both sides, to eliminate the 2, we would need to divide by 2. 2 divided by 2 cancels. X equals 0 divided by 2, which is 0. My other factor, x minus 3. Remember, I told you an easy way to move numbers across the equal sign is to change their positive negative signs. So if it's negative on the left side of the equation, when I move it to the right, it's going to be positive. So x equals positive 3. These are your 2 answers, x equals 0 and x equals positive 3. Your x's are known as roots. We've talked about this before, but I don't want you to forget. So again, our 2 different answers. One of these answers is repeating. The 3 is the repeating due to the square in the original factor. It was originally squared, so this guy is known as a repeated solution. A little side blurb on repeated solutions. Repeated solutions. If it's raised to an even power, again, this would be an example of one raised to an even power. When you graph it, it's going to bounce off of the x-axis. So again, raised to an even power, it's going to bounce. If your factor is raised to an odd power, when you graph it, it'll cross the x-axis. Super important. Now again, it's only a repeated solution if there is an exponent. So again, these are our two factors. We had 2x and x minus 3 squared. We set them both equal to 0. When we got our answers, our 3 is known as a repeated solution because the original factor was squared. So repeated solution, this guy is an example of one. All right, so now that I'm talking about graphing, we need to find the zeros and graph. Here's example 2. F of x equals x cubed plus x squared minus 6x. The steps are always going to be the same. First, we have to factor it, and the first step of factoring is always find your GCF. Please keep in mind that f of x is just terminology. It can be replaced for 0 when we're solving. Now that we've got it set to 0, we'll go ahead and find our greatest common factor. Remember, we look at our numbers first. I've got 1, 1, and 6. There's never going to be a greatest common factor if you have a 1. Remember, the only thing that goes into 1 is 1. We'll take a look at our x's, though. Each of these terms does have at least one x. That is your GCF. So we're going to go ahead and take that out. Each term has to be divided by your greatest common factor. X cubed divided by x leaves me with x squared. Don't forget, if you're lost on this, it's just subtracting exponents. 3 minus 1 gives me 2. Moving on to the next one, x squared divided by x is x, and negative 6x divided by x is negative 6. I want you guys to pause this video and take it from here. We need to finish factoring and then solve. If you get lost, look back at the first example. All right, from this point, you should notice that you have 3 terms again. 3 terms indicate that I have quad form, and I can set up my X puzzle to solve it. Negative 6 being on the top and positive 1 on the bottom. I need two factors that multiply to give me negative 6, but add to positive 1. Those factors are 3 and negative 2. Writing out our answer, we have x, well, I should say writing out our factor. Bring down your GCF, x plus 3, and x minus 2. Each of these terms, these are our factors. Actually, I want you guys to write that down. When you have the parentheses out to the side, these are known as factors. and we're solving. So we're going to take each of our factors and set them equal to 0. X equals 0, x plus 3 equals 0, and x minus 2 equals 0. Solve each of the problems. Obviously, x equals 0 is already solved for you. There's one of your roots. Positive on the left, if I move it to the right, he will become negative. So x equals negative 3 is the second root, and x equals positive 2 is the last root. So here are my three answers, our three roots. Notice that none of the factors were repeating. None of these had any squares or cubes or anything like that. No exponents. Let's go ahead and graph this. Just set up a little graph on the side. Remember that your solutions, or your roots, are the locations where your graph will cross the x-axis. So basically, I can tell you exactly where the graph will cross. It's going to cross at 0. It's going to cross at negative 3 and positive 2. Now remember, whenever you're graphing, you are going to need to know your end behavior. So we're going to just set up our degree and our lead coefficient to figure out our end behavior. We're always going to look at the original problem. Your degree is 3, which is an odd number. Your lead coefficient is 1, and it's positive. Remember, when we do this, here's our shorthand graph. Your lead coefficient tells you about the second arrow. Your second arrow is going up, but the degree is odd, so that means that my arrows must be going in opposite directions. So I know that my graph needs to be going down on the left and up on the right. So from the leftmost point, I'm going to go ahead and draw my graph going down. From the rightmost point, I'm going to draw the graph going up. Now none of these were repeated, so I don't have to worry about the graph bouncing off of the x-axis. All of them are going to cross over the x-axis. All right, if you missed any part of that, please pause the video and go back and check it out again. Here is number 3. We have f of x equals x to the 4th minus 8x squared plus 16. Now, from our factoring rules, you have 3 terms. Anytime you have 3 terms, you can go ahead and set up your x puzzles to solve that. 16 on the top and negative 8 on the bottom. My two factors that have to multiply to give me 16 but add to negative 8 are negative 4 and negative 4. Writing our answers, or I should say writing our factors. We started with x to the 4th. That means one of our factors have to start with x squared, and they're both minus 4 based on my x puzzle. Okay, continue factoring. We always want to look at what is inside our parentheses and make sure that it can't be factored further. Hopefully you notice that we have a difference of squares. They're exactly the same, but they are both a difference of squares. Difference of squares break down into 2 parentheses. We take the square root of each term. Square root of x squared is x. Square root of negative 4 is 2. One's positive, one's negative. Keep in mind, you just broke down only this guy. You have to break down the second one as well, although it does break down exactly the same. So we have x plus 2 and x minus 2. Okay, notice that we have our x plus 2. We have 2 of the exact same things being multiplied. You can write that out as x plus 2 squared. Same thing goes for my x minus 2's. They're exactly the same being multiplied. You can write it as x minus 2 squared. Neither of these things can be broken down any further. These are my factors. I can set them equal to 0 and solve. X plus 2 equals 0. X minus 2 equals 0. Solving for x, if it's positive on the left, when I move it to the right, it will be negative. Same goes for this guy. Negative on the left, positive on the right. My answers are x equals -2 and x equals +2. I want you to ask yourself if these guys are repeated solutions. Hopefully you've looked back up to the factors and noticed that both factors were squared. These are both repeated solutions. Super important. Both of them. Repeated solutions. I need to know this for my graph. So when I come over here to graph, I know that I've got some repeated solutions that I need to watch out for. First thing I need to do is go ahead and plot my x's. It crosses at -2 and +2. I can go ahead and look for my degree and my lead coefficient so that I know about my end behavior. Degree comes from the original problem, it's even. Lead coefficient, again from the original problem, it's positive. My shorthand in behavior. Lead coefficient tells me about my second arrow, which is going up. It's even, so I know that both arrows must be going up. This tells me that the left and right side are both going up. I can go ahead and graph that. What I don't know is if my graph crosses over the x-axis or if it's going to bounce. So when I go back up to my repeated solutions, that's going to tell me. If it's raised to an even power, both of ours are. If it's raised to an even power, it's going to bounce off of the x-axis. So I know that this guy is going to bounce up and come and cross over somewhere. My next question is, where is the y-intercept? Your y-intercept is always going to be your constant. So whatever your constant is, that's where your graph crosses the y-axis. In this case, it's 16. Obviously, 16 is going to be way up here on my graph. I'm just going to draw a line here and call it 16. Again, both of my points they bounce, so it's going to bounce off of the x-axis, cross over the y-intercept, and bounce again. Okay, just a recap on that. I found my solutions, which we plotted on the x-axis. I also needed to find my y-intercept, which was 16. I have to know where the graph crosses over the y-axis. It's always going to be your whole number, or your constant. We talked about our end behavior. We knew that the graph should be going up on both sides. And our repeated solutions, it told me that the graph will not cross the x-axis, but it will bounce off instead on both of them. I'm going to give you another one just like that. I want you to try it on your own. This is example 4. We have f of x equals x to the 4th power minus 18x squared plus 81. Again, this is exactly like the previous problem. Stop the video and try it on your own. All right, coming back to me. First step always is to factor. Our f of x, we can go ahead and substitute a 0 into there. We know that we have 3 terms, so automatically I should be setting up my x puzzles. 81 on the top, negative 18 on the bottom. 2 terms that multiply to give me 81 but add to negative 18 are negative 9 and negative 9. Notice that we're starting with x to the 4th, so my answers should start with x squared. I've got x squared minus 9 and x squared minus 9 again. Please pay attention to what is left inside your parentheses. I hope that you picked out these are both difference of squares. 9 is a perfect square. Difference of squares has to be broken down further. Difference of squares always breaks down into 2 sets of parentheses. We take the square root of each term. The square root of x squared is x. The square root of 9 is 3. One's positive, one's negative always. Keep in mind, I only broke down the first guy. The second guy also has to be broken down. He does break down into the same thing. x plus 3 and x minus 3. You do want to simplify this. We've got two x plus 3's. They're being multiplied. I can simplify that into x plus 3 squared. Same thing for the x minus 3's. You've got repeated solutions. Just make a mental note of that. But we're going to have to figure out what they are. We're going to set each one equal to 0. Positive on the left means it will be negative on the right. Negative on the left, when I move it, it will be positive equals positive 3. So I've got x equals negative 3. I'm going to rewrite that. And x equals positive 3. Keep in mind, again, both of these guys were repeated solutions. Repeated solutions. All right, let's move over and graph this. So I know my two x's are negative 3 and positive 3. Negative 3 and positive 3. My y-intercept. Remember, your y-intercept is your constant. 81 is way off of my graph, so I'm going to do the same thing I did last time. I'm just going to make a mark here and call it 81. Now, I do need to know what's going on, so I need my degree and my lead coefficient to figure out my end behavior. My degree is 4, so it's even. My lead coefficient is positive. That means my lead coefficient tells me what my second arrow is doing. It's even, so they're both going in the same direction. Now, when it comes to my x's, I have to know, is it bouncing off or is it going to cross over? Your repeated solutions were even, just like the last problem. So at each of my x's, it is not going to cross the x-axis, it's simply going to bounce off of it. In behavior, and then we just said it will bounce off of the x-axis on both of them. All right, if you have questions on this, go back and review example 3 or example 4. We're going to move on. Here's number 5. I've got x cubed minus 8x squared plus 11x plus 20 equals 0. Back to our factoring rules. We have 4 terms. There's only one option when we have 4 terms. It's grouping. We group the first two and group the last two. Grouping is pretty much a matter of GCF. Once we've grouped our first two, we're going to look for the GCF between x cubed and negative 8x squared. They both have at least 2 x's. X cubed divided by x squared leaves me with x. Negative 8x squared divided by x squared is negative 8. There's your GCF. We're going to do the same thing for the second set. I've got 11 and 20. I need the greatest common factor between 11 and 20. Use your calculators to figure that out. Hopefully you found that there was no greatest common factor between 11 and 20. The only things that go into 11 are 1 and 11. Unfortunately, 11 does not go into 20. There is no GCF. Okay, so what do I do? That leads us to the next thing. Not everything is factorable. You may run into situations like this where you can't factor it. What you're supposed to do next, if you run into this, is called the rational root theorem. Rational root theorem. This is what it says. If p of x is a polynomial, with integer coefficients, then every rational solution will be. If p of x is a polynomial with integer coefficients, then every rational solution will be p over q. P stands for factors of the constant, and Q is factors of the lead coefficient. Okay, again, we use the rational root theorem when the polynomial is not easily factored. Use when polynomial is not easily factored. Or you could say is not factorable. Important things here. Okay, here's an example of what I'm talking about. This will be example 6. Find all solutions of x cubed minus 8x squared plus 11x plus 20 equals 0. Find all the solutions. So this is the problem that we just looked at a second ago, where we had 4 terms and we tried to group it, but we couldn't. So I already know that this problem is not factorable. I'm going to have to use the rational root theorem. First thing, our P and our Q. Those are going to be our x's. So our P, we're just going to start with, what are the factors of the constant? This is the constant, the guy with no x's, he's always the constant. So we want to just start listing factors of 20. Factor of 20, 1, 2 goes into 20, 4 goes into 20, 5, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 does. There's one more. Don't forget 1 and 20. 20 does go into itself. Please keep in mind, all of these are positive or negative. Positive or negative 2 does go into 20. Positive or negative, always. Divided by, now those were our P's. Those are all the factors of the constant. We're going to list them all out. And then all the factors of the lead coefficient. So all of these divided by my factors of my lead coefficient. Lead coefficient in this case is 1. The only factor of 1 is 1. My lead coefficient was 1, and the only factor of 1 is 1. So I divided every single factor of the constant by the factor of the lead coefficient. My second step is test using synthetic division. So first thing I'm going to start, we're just always going to start with 1. And to be honest, positive 1 is easier than doing negative 1. So where I'm coming up with this is 1 divided by 1 is 1. We've got positive and negative 1 to try, positive and negative 2, positive and negative 4, so on and so forth. Start with the easiest one, positive 1. So x equals 1. So when I set this up with my synthetic division, still works the same as it always has. We just need our coefficients. I have 1, negative 8, 11, and 20. Make sure that no one's missing. In this case, it's not. We've got x cubed, x squared, x, and then our regular number. The number on the outside is whatever you said it was. Again, there's no need to flip the sign. They're telling you automatically we want to try 1. Steps are always the same. Drop the first one. Do your multiplying. 1 times 1 is 1. Add -8 plus 1 is -7. Continue the cycle. 1 times -7, -7. 11 minus 7 gives me 4. 1 times 4 is 4. Adding, we have 20 plus 4 gives me 24. This is your remainder. Now we know from the remainder theorem that if the remainder is not 0, then this is not a factor. So the answer to this guy is nope. X equals 1 is not a factor. So we got to move on and try the next one. We already did +1. It does not work. Let's try -1. -1 on the outside. My coefficients are the same. 1, -8, 11, and 20. Okay, drop our 1. -1 times 1 is -1. -8 minus 1 is -9. -1 times -9, +9. 11 plus 9 is 20. -1 times 20 is -20. 20 minus 20 is 0. So in this case, our remainder was 0. So our factor of x equals 1 is a factor. Now let's write that out. Yes, it's a factor, but it was x minus 1. So in order for me to get this, the actual factor is x plus 1. Okay, this is a flip the sign. We have to change it back. Now that's part of the factor. The remainder comes from what you have here. So remember that this is your remainder. These are your whole numbers, your x's, and your x squareds. So the other factor comes from your answer. We've got 1x squared minus 9x plus 20. So once I arrived at a remainder of 0, my first factor comes from what I divided by. Again, you'll want to flip the sign. The second factor comes from the answer. You should now see that you have 3 terms. You guys know how to factor with 3 terms. Set up your x puzzle. 20 on the top, -9 on the bottom. My 2 factors, -4, -5. So we have x plus 1, x minus 4, and x minus 5. If they're in parentheses, they are the factors. They want us to find the solutions. That simply means put everything equal to 0. Now, remember what I said, if I put x plus 1 equal to 0, if it's positive on the left and I move it to the right, it'll be -1. Same goes with my -4. I don't actually have to set it equal to 0. My x minus 4 equals 0. If I move it to the right, it'll become positive, and my -5 would become positive as well. So my solutions, -1, +4, and +5. Okay, just to run back through that one more time. Again, if you cannot factor something, we have to list out the factors of the constant divided by the factors of the lead coefficient, which is what we did right here. The factors of 20 are listed. The factors of my lead coefficient, which is 1, they're listed here. We're going to use our synthetic division to figure out who works and who doesn't. Always easiest to start with +1. We did synthetic division with +1. Our remainder was not 0 and it doesn't work, so we moved to -1. When we did our synthetic division with -1, we did get a remainder of 0. That tells me, bam, I have a factor right there. Your first factor comes from what you divided by. If it's -1, you know your factor is x plus 1. The other part of your factor comes from your answer. Again, it's always in the order of remainder, number, x, and x squared. We wrote out our answer. When I looked at this to know if it was needed to be factored any further, I have 3 terms. 3 terms means I use my X puzzle. Writing out my final list of factors, I got x plus 1, which I brought down, and I simply wrote the answers to my X puzzle as the remaining factors. Solving, you guys know how to solve. Each factor has to be set equal to 0. Shortcut, change the sign. X plus 1, my answer would be 1. My -4 would be positive, and my -5 would be positive. If there's any trouble with this, please go back and review it. You guys have 10 problems to complete online. I must see all the work on paper and will be expecting it to be turned in when I return to you on Monday or Tuesday.